Hello and welcome back to Harry's Jeti Clinic. In this episode we're going to be looking at a rudder to aileron mixer, as might be used for knife edge flying, specifically where you've got two aileron servos, which is very common, and you need an asymmetric mix. For instance, with left rudder you need to apply a lot more aileron than you do with right rudder. Now you're probably thinking, well, this is dead easy, this is a very common mix. Why on earth are you doing a video on this? Well, the reason is, yes, it's easy to do in Jeti, but it's not done where you think it would be done. And if you do it in the place that common sense tells us it should be done, it's not going to work. And you may not spot why it's not working, but realize that for some reason things aren't going right in the air. And the reason is that there is a quirk in the software. Some might be less generous and say that it's a bug or even a downright error, and I do wish Jeti would fix it. Jeti is not alone in doing this. When Multiplex brought out the Royal Evo, it had the same error, shall we say. And after a lot of criticism, Multiplex actually stated on their website that this behaviour was actually a feature. Nobody could get them to explain why doing it wrong was a feature, but there we go. Jeti has managed to replicate it. However, enough of this blather. Let's go in and have a look at it. So we go in and fine tuning, set up a free mix, add from rudder to ailerons, come down here, set in a master value of 100%. Yeah, and you're thinking, oh, what's going on here? Now, come along here to the curve. Now, this is where you think we'd do the asymmetric mix. You would change that from standard to a 3-point. Come down here, and let's leave that point where it is. We're going to use exaggerated travel so that you can see the effects. And what we'll do is move this point down to here. So we're saying that when we move left rudder, we should get a lot of aileron travel, and when we move right rudder, we should get very little aileron travel. Okay, let's have a look at what that does at the servos. Here's our two servos, aileron servos, left and right, and there's the aileron stick moving them. Now let's look at what happens when I move the rudder. I'll move the rudder left. Remember, rudder left should give lots of travel. Watch what happens. Oh dear. The left servo moves a lot, but the right servo barely moves. What happens when I move right rudder? Focus please, camera, that's better. So your right rudder should give very little travel. And what actually happens? Well, this time the right servo moves a lot and the left servo barely moves. So left rudder, right rudder. It's completely wrong. What it's done is now just give unequal travels on either side, which is going to reduce the roll rate because one of your servos is barely moving. But it's also going to shift the roll axis because you've now got an asymmetric couple. But more to the point, you're still getting an equal roll rate both ways. Just not quite what it should be. And you still, even though we appear to have reduced what should be the travel on the right side, you're still getting massive travel on one of your servos. So you're just not getting that tiny roll rate. And here's the problem with it. Because this mixer curve is the obvious place in which to set your asymmetric mix. Okay, let's put that back to 100 and find out the correct way to do it. So, come down here into the mix output. Servo 1 down here, servo 2 down here. Now, I do hope, as I've stressed in so many of my videos, that you've plugged the leftmost aileron servo into the socket marked S1 and the next one to the right into the socket marked S2. Jeti works from left to right. It's like reading You go from left to right. Aileron and flap servos are numbered from left to right. If you plug them in from right to left, then yeah, things like this work, but you've got to remember that S1 here, left and right, is actually the other way around on the model. And it's going to affect your differentials, mixes, what do you call it, flight mode trims, all sorts of stuff is going to be like the wrong way around. And I've even seen people with 4 flap servos plug them in numbered at random, in effect, not even doing it right to left, but sort of right, left, right, left, this kind of thing. So please, I know I belabor the point, but just get used to it. Plug them in left to right. Okay, enough of that one. Mix output, servo 1, that's our left-hand servo. Let's see what happens if we turn that value way down. The plus and the minus, by the way, are not up and down travels, because of course the radio cannot know how your linkages are set up. But it's to do with, well, just a way of differentiating it. Okay, servo 1. Mix output's 20%. Let's see what happens if I move left rudder. Still full travel. Okie doke. But if I move right rudder, there we are. Servo 1 on the left has now got reduced travel that way. Now you might think, therefore, that all we have to do is change the same mix output on servo 2. Let's see what happens. Go back here, left rudder. Oh dear. It looks like we're back in the same problem. Well, we're not. It's simply that what you might think you do along the same line, you don't. That one would stay as 100, and you come down. Oops, I'm being a numpty, aren't I? Bring that one down to 20. And now, lo and behold, here's right rudder, left rudder. And now we've got our asymmetric mix. So, as you can see, it is simple enough to do, but you have to be looking in the right place to do it, and the obvious place to do it doesn't work. Okay, bye for now.